Okay, so for section 5.3, we're looking at solving trig equations. So we're going to use what we learned in section 5.1, 5.2 to actually solve for x. So what this means is we're not necessarily looking at just identities, we're looking at equations that have specific requirements for each side to be equal. Okay, so our central question is, how can I use trig identities and the unit circle to solve trig equations? So the unit circle should be out, your trig identity should be out as you're solving these equations. All right, so here's some steps or some ways we can kind of solve trig equations. If you only have one trig function in the equation, doesn't matter how many there are, but one type of trig function, then you can isolate it, get it to one side, and then use your calculator to solve. Okay. If you have various trig functions, like a sine, a cosine, a tangent in your equation, then we have to start to use some of the following. We have to use some identities. We try to factor. We try to square. As long as we can kind of narrow it down and simplify it to something easier to solve, that's our goal. All right, so let's look at an example where there's only one trig function. It says solve for x in the interval from 0 to 2 pi. So our answers need to be from 0 to 2 pi. We're not going further than that. So we have 2 sine x plus 1 equals 0. And now, since we're trying to solve for x, we're just going to isolate sine x. Because right now, x is trapped in there with the trig function of sine. So we're going to try to isolate sine. So we're going to move away the 1, move away the 2, so that sine x is by itself. So I'm going to subtract 1 from both sides. So we end up with 2 sine x equals negative 1. All right, subtracted 1. And then again, I want sine by itself, so I'm going to divide both sides by 2. That way, when I divide by 2 on both sides, I end up with sine x equals negative 1/2, which now that sine is isolated, I can go to my unit circle and say, okay, when is sine equal to negative 1/2? Okay, even if there's more than one answer, that's fine. I'm just looking for where the places when sine is negative 1/2. Now we know that everything's positive in quadrant 1. Cosine is negative here, but sine is positive. I don't want sine to be positive, I want sine to be negative. Sine is actually negative in quadrant 3 and 4. Because remember, sine is our y coordinate, okay? And y is negative down here in quadrant 3 and 4. So I'm looking in quadrant 3, quadrant 4 to see, well, where is sine negative 1/2? When you have your unit circle in front of you, you can just look and kind of find it here. If you didn't, you could use your reference angle and say, I know over here, yes, sine is positive, but at 30 degrees, and actually I'm going to use radians since we're asked to go from 0 to 2 pi, that means keep our answer in radians. So at pi over 6 radians, sine is positive 1/2. Put root 3 over 2, comma 1/2. Sine is positive 1/2. That lets me know that the reference angle of pi over 6 is exactly where sine is 1/2. I just need to be down here so that it's negative 1/2. I'm going to go pi over 6 below the x-axis, which would be 7 pi over 6. All right, this is essentially 6 pi over 6 because that's 1 pi. So if I go pi over 6 down, I'm here, and I know that sine would be negative based on my reference angle here. And I also can go pi over 6 degrees below the x-axis on the right, which would be 11 pi over 6, and that's also where sine is going to be negative 1/2. Okay, so if I didn't have the unit circle in front of me, if I know this first quadrant, I'm good to go. So I know that x is 7 pi over 6 and 11 pi over 6. And that's within our interval of 0 to 2 pi. Okay? Parentheses around the 2 pi means we don't want to repeat our answer of 0 and 2 pi, this location. So we're just going to go from 0 up to anything before 2 pi. All right, let's look at one more. Sine squared x equals 3 cos squared x. So it's now a case where we have a sine and a cosine. We have two different trig equations, two different trig functions. So it's our job to rewrite this, hopefully if we can, using some identities so that we only have one trig function. So I'm going to take out sine. We know that sine squared lets us look at the Pythagorean identities, which tells us that sine squared is equal to 1 minus cos squared. So I'm just going to rewrite sine squared in terms of 1 minus cos squared. Right side I didn't do anything with. And because I'm solving, I'm allowed to add and subtract to both sides because we're trying to show when this is true. when this equals? What x value is it equal? Is the left side equal to the right side? Okay. So now I can say, well, I have cosine squared, I have cosine squared. Let's put all the cosine squareds to one side to isolate. So I'm going to add cosine squared here, add it here. So I end up with 1 equaling 4 cos squared x. And again, I'm trying to isolate my cosine. Right now it's cosine squared, but I'm trying to isolate my cosine. So when I divide both sides by 4, I get 1/4 equals cos squared, which is almost good, except for the fact that when I have cosine squared, I need to make sure that I'm undoing that squared, and then I'll be able to look at the unit circle. So how do I undo a square? I square root both sides. So now because I square rooted both sides, I have 1/2 here, right? Square root of 1, square root of 4, but I have plus or minus. So positive or negative 1/2 equals cosine x. And again, I'm looking for x. I'm looking for where on the unit circle, is cosine positive 1/2 or negative 1/2, which means I need all 4 locations. And again, I can look at my unit circle, use quadrant 1 to help me out. I know that and again, we're looking at radians. So at pi over 3, cosine is 1/2. And so I'll use this as my reference angle. This is 60 degrees, right? So everywhere I go, about 60 degrees above the x-axis, below the x-axis, I'll have all my angles. So I'm going to go here to 2 pi over 3. I'm going to go here, oops, a little far over, but 4 pi over 3. And lastly, there we go. Lastly, I'll go here to 5 pi over 3. So those are my 4 answers because I want a positive and negative. This is my reference angle, and anything that same distance on the x-axis is going to give me my answer. So I'm going to say pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3 are all my answers for x.